Hello, everyone. Welcome to the session. I'll still optimize my stuff from my end. And first of all, I'm glad to welcome you here for a variety of reasons, because I'm excited on delivering this message, because it's a sign of the times, but also because I'm glad that you selected our webinar and decided to attend it, because I know you have options and there's plenty of webinars out there, and webinars aren't the cool thing they were in mid-2020. So thank you for taking time out of your busy schedules to be here with me. So this presentation, this webinar will be about what happens when CDNs fail and how you can protect yourself and stay online by using Varnish as an origin shield. So that's the topic of today. So without any further ado, hi, I'm Thijs. That's how you pronounce that. I'm a Dutch-speaking Belgian, located in Belgium, Europe, of course. More importantly, I'm the tech evangelist at Varnish Software. And I'm assuming that most of you know who Varnish is. If you're new to this, Varnish Software is the company behind the very popular open source caching software called Varnish Cache. But we're also the creators of Varnish Enterprise, which is the commercial offering. But today we're going to talk about content delivery networks, or CDNs, and they cache as well. And I must admit that some of these CDNs actually use Varnish to build up their CDN platform. Now, what's particular about CDNs, because we can't make assumptions, I cannot assume that everyone here in the group knows what a CDN is. It's actually a collection of caching servers that is distributed across the world in an attempt to accelerate application content, web content in general. And by placing it in strategic geographic regions, it tries to solve three particular problems for people who have web platforms. That is availability, capacity, and latency. In terms of availability, the main purpose is by caching content on a separate machine, you'll make sure that the content remains available, even though the origin might fail for a variety of reasons. It might be an outage due to technical concerns, but it might be capacity related as well. And that's what CDNs do very well too. They have enough capacity in terms of number of servers, in terms of performance, but also in terms of networking to ensure that even though you have thousands or hundreds of thousands of parallel requests on your application, that the performance is really good. And a third thing it does is it does well in terms of latency. And certain web applications or domains of application for the web are very sensitive to latency. And I would particularly like to refer to video streaming. If latency increases in video streaming, it has a direct impact on the user experience. And CDNs can reduce this latency because they're located not close to where the origin server is, not close to that data center, but really close to the end user. And they do that by building separate points of presence, or POPs as we call it. You might have various POPs in the United States to cover let's say the East Coast, West Coast, Midwest, the South, you name it. In Europe also, you might have various POPs, and actually throughout the world. And by doing this, by spreading this out, latency can be significantly reduced based on the geographical location of the user. And then you have routing software that identifies location of the user and sends it to the right point of presence in order to distribute the capacity across many networks, because then again, an individual server can only process that much bandwidth, that much concurrent requests. So by doing these three things, your application is pretty safe. And one must appreciate the fact that these CDNs are crucial to the internet as we know it. They actually carry the internet, as you can see in the image I used for the metaphor. Without these CDNs, we would not have the quality of experience we have right now. And as the internet is consumed for 80% by video applications, well, the buffering would increase, live streaming and video on demand experience would reduce, websites would load slower. So CDNs are crucial for the internet. But that being said, and that's my first point I was trying to make, let's go to the second point. What happens when they go down? What's the impact? And mind you, this is not a far-fetched theory or some sort of hypothetical use case. These things happen. They actually happened this very month. Earlier this month, a very big CDN, the public CDN, had an outage for a couple of hours, if I'm not mistaken, and seemingly took down half of the internet. Now, I use the word seemingly because in terms of number of websites and web applications that were offline, it wasn't like literally half of the internet, but there were some really high profile, very popular platforms that went down, and it seemed like half of the internet was down. Now, I'm not in the business of naming and shaming, and that company will remain nameless as far as I'm concerned, but these things happen, not just to the one company, they occur. And as a user, you need to protect yourself from that. And there's various strategies you can apply. Now, I'm not trying to use scare tactics here. In most cases, CDNs are quite stable, but you have to look at the risk for yourself. What happens when they go down? What is the strategic, operational, and commercial impact of these things? And if you cannot afford being down for, let's say, longer than a couple of minutes, when it starts costing you money, you need to find strategies. And these are the strategies that are viable. And most of these, not all of them, are really good solutions. But of course, as you look at the bottom one, origin shielding, it comes as no surprise that I'll focus on this one. But I'm not going to position origin shielding as the better alternative for the others. Each have their own context. And let me walk you through the various solutions. This is how a regular CDN works. So a client connects to a service. Usually that's a DNS-based service that uses www, whatever your website or web platform is. And whatever IP address is returned is determined by your geographical location. This request routing system is aware of your IP address, maps it to a geographical location, and finds the closest point of presence. Could be, in this case, a CDN with a US POP, so POP stands for point of presence, or an EU POP. And these connect to the origin if the content that is requested by the client is not stored in cache. That's how a CDN works. And these individual POPs are just a collection of caching servers similar to Varnish, or exactly like Varnish. For private CDN, these aren't services, but these are POPs you build out yourself with software like Varnish or likewise. Here's the next one, multi-CDN. Let's assume you don't trust or you can't risk putting all your eggs in one basket and you decide to have multiple CDNs next to one another. They could be in an active passive setup, which means all your traffic goes to CDN 1, except if a POP or the entire CDN goes down, then your secondary CDN starts kicking in. It's a viable solution, but in a lot of cases, you're going to go for an active setup, which means that all these CDN nodes and POPs are going to run next to one another, and the intelligence is going to be at the request routing side, where data-driven decision-making is used, and where it's not only going to be about geographical locations, such as US or EU, but also which POP has the lowest latency at this moment, where's the least network congestion rather. And on a request per request basis, this is going to be examined and the right POP is going to be chosen. That's multi-CDN. And that is an excellent solution. However, there is added complexity. There's no real economy of scale in this because you have to buy all these licenses or pay the bandwidth, have the setups, make sure they work with one another. So there's a bit of complexity, but for a lot of companies, these things work, especially the ones that operate at a pretty big scale. Another solution is doing it in a hybrid way, and that's where our offering usually comes in. Now, mind you, this is not a presentation about hybrid CDN, so I'll quickly mention it and leave it be then. If your origin, for example, is hosted in the EU, you can build out a local POP that satisfies your local region, which might be a cheaper solution, a solution that is very stable and you have full control of. And then you might have some data center space where you can put a US POP. And this runs right next to your public CDN, where the bulk of the traffic will probably be handled by your public CDN, and then trusted traffic from specific regions, or when heavy network saturation occurs in your public CDN, the private part of your hybrid setup is going to kick in. That's an offering where we're pretty good at, where we do lots of business. Another solution is origin scaling. Now, I told you that all of the solutions were good ones, except, and then I corrected myself by saying that most of them are good. This is a bad one, but it still can be considered a solution. Let's say your points of presence, your entire CDN explodes. It's no longer available, which is what happened earlier this month. Well, what you can do then from a request routing point of view is promote your origin as the single point of entry, but your origin is hardly going to survive. So what you can do is scale out your origin, but that's going to be a really expensive matter because caching will not apply. And although web traffic might be scalable, what do you do with databases and such? So in the end, this is going to be a very costly situation. And this is in the realm of auto-scaling, what a lot of people do in the cloud without thinking about content delivery. And as the famous poet and rapper Notorious B.I.G. once said, more money, more servers, more problems. In general, just more complexity. Which brings us to the solution I'm going to talk about today. Is Varnish as an origin shield. And this is the diagram of the origin shield. The origin shield doesn't stand alone. It is an extra tier of caching that is bound by the same gray box. So it's in the same location as the origin, and it offloads the origin towards the CDN. Because the CDN, and that might come as a surprise, various CDNs have so many points of presence and so many individual nodes in these points of presence that are not always synchronized, so that when content needs to be revalidated and you have a global audience like pulling in this data, that the revalidation process to the origin from all these nodes and all these hops can be like a mild DDoS attack, which has a heavy impact on the stability of the origin, which is counterintuitive because the entire point of having a CDN is having that stability. So by putting in an extra tier of caching, in this case, that will be Varnish, you're basically protecting your origin from the impact of your CDN sometimes. Now, that doesn't always happen. That happens in specific cases. But where the origin shield really shines is when the points of presence fail, your request router will promote not just the origin, but your origin shield as the point of entry, as the edge tier, as we call it. And then the question is, how long can it withstand the heavy pressure? And I can say that both as an employee of Varnish software, but also as a very long time Varnish user, that the performance is quite impressive. An individual Varnish node can process up to 800,000 requests per second. The latest benchmarks, which are very fresh, they're only a couple of days old. There will be an announcement real soon that on specific hardware that we tested it on, we could push Varnish to process over 380 gigabits per second on a single box over TLS. And cached content can be served with sub-millisecond latency. Now, these are benchmarks that are very real, but are done on very, very good hardware. Your performance, your mileage will vary, of course, and your performance will depend on how good your hardware is. But what is also interesting about that statement is I'm 100% sure that we haven't reached the top yet. We haven't reached the maximum yet. If we have better hardware, I'm pretty sure Varnish on an individual node will perform even better. So that being said, it's a good thing to have your origin shield, and Varnish is an excellent choice because based on these official benchmarks that we'll communicate about very soon, we can say that we're the fastest caching and content delivery technology on the planet right now. And other people tend to agree with that statement as well. About 4.8 million websites globally use Varnish. And if you look at the top 10,000 websites, about 19% uses us. However, and this is where I want to add nuance to these seemingly wonderful numbers and wonderful statements, an origin shield is not the same as a CDN. In this webinar, we're not building CDNs. CDN has a lot more complexity. And what we're building here as an origin shield is a plan B. If your CDN fails, you have a plan B, and it's a temporary plan because we're not expecting CDN to be offline for days without interruption. It's going to be a couple of minutes, maybe a couple of hours at worst. And what you need to do is provide an alternative to downtime. So is the origin shield going to perform on par with your CDN? Probably not. And that is not due to the power of Varnish. That is due to limitations in terms of network capacity and the impact of network saturation. As mentioned before, an individual node can only process so much incoming traffic in terms of bandwidth, in terms of concurrency, and that's due to your hardware, your CPU, your network cards, but also your operating system's kernel. So if we look at origin shielding from a plan B point of view, there's the three promises of the CDN, the three things it does in general terms that I've revisited. In terms of availability, you'll be fine because it is very, very powerful. Varnish is very powerful and it will protect your origin. So if 800,000 concurrent requests come in, Varnish will protect you. But capacity is a different one. Capacity depends on the pipe you have, the hardware you have. So, and I will come back to that in a second. It all depends on the use case and the type of data you're going to send. So if it's text-based data that is pretty compact on a response basis, like a website, capacity will be fine. But if you do video, which is a lot bigger, higher concurrency usually, well, capacity is not guaranteed. And what will definitely not be guaranteed, so although I was a bit lukewarm on capacity, latency can become a real problem, especially since origin shielding is not distributed across the globe. It's just in the data center where your origin is. Its sole purpose is to protect the origin. So if my origin and my origin shield is located in the EU and my client connects to my web service from West Coast USA, well, then there might be latency. Latency that is due to, you have the transatlantic latency, but then also the continental latency between East and West Coast. So it might take a second for a page to load, which in some cases is acceptable and others is unacceptable. But again, it depends, and I'll translate these 3 points into domains of application. For websites, it's usually fine because that's small textual data that might be compressed into gzip or broadly compression by your web server, even by Varnish. It will be very compact. We're talking about bytes and kilobytes. Whereas for images and documents, it also depends on the concurrency, the size of the images, the number of, the amount of bandwidth that is reaching you. So the websites that the images and documents that accompany your website, such as regular images, CSS files, web fonts, JavaScript, that probably will be served reasonably fast. But when it comes to online video, well, all bets are off because these video files, if you're streaming 4K, you might end up needing 25 megabits to stream that in 4K. So you know you're going to need a big pipe to deal with that. And that is not always going to be available in your local data center where your origin shield is located. However, you can scale your origin shield as much as you want. Like you can start off with a couple of origin shield nodes, Varnish nodes, maybe 2 or 3, but you can scale that up. And eventually, when that starts making sense for you from an operational point of view, strategic point of view, commercial point of view, your plan B can just as well become your plan A, if you will. And what you've basically done is turn your origin shield into a private CDN or a hybrid CDN. And that is perfectly possible. It all depends on your needs. So before we go into the demo, I want to show you a couple of origin shielding features that Varnish has beyond the basics. So here's the list. We'll go over each one individually, but I do want to highlight the Akamai connector now because I don't have a dedicated slide on it. Akamai is a very popular large-scale CDN, and we have a connector for it in Varnish Enterprise, which ensures that the behavior, the caching behavior that is defined in Varnish is automatically synchronized with Akamai. Because that's what you have when you have an origin shield caching tier behind your edge tier, which is your CDN. You must ensure that there is similar behavior, because if Varnish caches differently than your CDN, there might be problems. You have to take care of that, something you need to consider. But if you use the Akamai connector and you use Akamai as your CDN, well, behavior will be synced and you only need to define it at the Varnish level. But let's look at the other features as well. Request coalescing is a major feature in Varnish. Now, imagine having not 1, not 10, not a dozen, maybe hundreds or thousands of requests coming into Varnish at the same time for a piece of content that is not stored in cache. Other caches will cause a sort of thundering herd effect, which means all these cache misses will cause the same amount of connections to the origin. And that is unacceptable because the origin isn't equipped to deal with that. That's why we put a cache in front of it in the first place. So that is not good. Varnish has a feature called request coalescing, where similar requests for the same object are grouped, coalesced, if you will, and are queued on a waiting list. And these are satisfied by a single request to the origin server. So when the origin responds, all these queued connections, queued requests, will be streamed through at the same time in parallel. So if there's 1,000 people waiting for the same content, there is no head of line blocking. You shouldn't queue sequentially. It's done in parallel and it's streamed. So that means it's byte per byte, not waiting until the entire content is buffered. And that heavily increases the quality of experience. Another feature is grace mode. And grace mode deals with origin shielding from an entirely different point of view. So what you can do if content is past its time to live. So I want to quickly highlight that if you store something in cache, it's a temporary thing. You define the lifetime of the object in cache. And when that time to live expires, it's time to revalidate. So that increases the load on the system when revalidation happens. But thanks to grace mode in Varnish, and the grace value in Varnish is configurable, but the standard value is 10 seconds. So an object can be served stale 10 seconds past its lifetime, while a new version, a new copy is fetched from the backend. So that means all these users that are fetching the content that is considered stale, they don't need to queue, they don't need to wait for the origin to respond. The old version is served, the stale version is served, and you can bet that the next time you'll visit it, you have the updated content without having to wait. So that's also a very popular feature. And it's our implementation of stale while revalidate. Now there's also stale if error. And you can read through it, like you can read between the lines what happens here. We have a module in Varnish Enterprise for that, and here's a little bit of code. So if you use Varnish, you're going to leverage the Varnish configuration language, which is our domain specific language. And this is a little bit of syntax. So it's not a top-down programming language like C or PHP or other languages that have the same curly braces style, but that you program top-down. What you do here is you extend the behavior. And what we do here is import the stale vmod. Vmod is short for Varnish module. And we define a custom routine called stale if error. And we perform some logic on it. And that logic is triggered. I'll explain what the logic is in a second. After the backend has responded. So that means the object wasn't served from cache, and we needed to fetch the origin, and the origin responded. That's where we will call, as you can see, stale if error. And then the logic gets executed. And the logic is, if the backend response is status code, so whatever we got back in terms of HTTP has a status code higher or equal to 500, we know it's a server-side error. So 500 itself is an internal server error, 502 is a gateway error, 503 means backend not available. So if these critical errors occur, and we have a stale object, then we're going to revive the object. So that means we're going to reset the time to live without revalidating the content, because we know the content is bogus. So in this case, we do stale.revive. We set the time to live to 20 minutes. So it can live for another 20 minutes, and we'll serve stale content for another hour. So an hour beyond that 20 minutes, we'll be able to serve the same content if the backend doesn't properly respond. And then we deliver the content immediately and abandon the request routine. This happens both when the backend responds, but also when the backend is unable to respond, and that you see in VCL backend error. So if the backend fails, if there's no way to connect to it, we still apply that logic. And the trick is, and that's the only line I didn't discuss here, is by setting bresp.keep to a day. So that means even though the cache has expired and the object is past its time to live and past its grace time, we'll still keep it around for a day. That doesn't mean it gets served for a day, but it's still there. It's not evicted immediately. And that allows it to match the stale.exists condition, and that allows us to revive it. So that's a good one when your origin fails. So stale if error is about what happens if there is a failure at the origin. You still want to keep your platform up. Then another one is part of MSE, and MSE is short for the Massive Storage Engine. It is our Varnish Enterprise proprietary storage engine, and as the name indicates, it's built to cache massive amounts of data. And it's this mixture of memory and disk. Now, disk usually has a bad rep when it comes to caching, because we always consider disk to be slow and memory to be fast. But we've designed it in such a way, as you can see in the definition here, that the stores where the objects are going to be stored are in pre-allocated files, located on individual disks in this case. So imagine that you have two disks, disk 1 and disk 2, each 1 terabyte in size. Well, these pre-allocated large files will take 1 terabyte. And that ensures that there's no disk fragmentation, and that no files need to be opened per object, no directory listing needs to be made. Everything is streamed through these files. These files have what we call file system-like behavior inside, and that makes them so fast, especially if you host them on disks that are maybe NVMe SSD disks that are lightning fast. But that's just the baseline. The hot content will be loaded into memory, and our memory governor feature of MSE will ensure that the memory is scaled automatically due to the needs. So you might have memory that is required to handle all the threads, and the rest of the memory will be assigned to Varnish. And as a default value, 80% of your entire server memory is allocated to Varnish. This is tunable, of course, but there's a persistence layer behind this. Now, I want to get to the point why we have this. If you have MSE persistence, you can store more in cache. That's a primary benefit. If it doesn't all fit into memory, the disk is there as a secondary origin. It will protect you. It is very fast still, even though it's stored on disk. And it avoids having to expunge stuff from the cache and having to go back to the origin to get it. So that protects the origin in a way. But what it also does, and that might be surprising, is that the persistence layer can be used to protect your origin. Let's say when your varnish server would fail, maybe there's a network card failure or panic on the kernel. You have to reboot your machine, it comes back up, and thanks to persistence, the caches will be hot. Let's say you have a video on demand collection that is worth a terabyte or 2 terabytes in size. Well, if varnish restarts and the files are there, the cache is going to be hot. And those files can also be used to scale out your origin tier, or to scale out the varnish aspect of your origin shielding tier. You can load these files from backup, put them on new machines, start them up, and the caches will be hot. And as a final mechanism, it's a rather aggressive, I must say, and it's a sort of firefighting technique. But imagine, like, I'm from Belgium, I might have a platform, a web platform hosted in Belgium, and the majority of my traffic may come from Belgium, or the traffic that I hold near and dear, the users that are important to me, are located there. But there might be traffic from all over the world, but we know our network cannot handle all of that because the CDN is down. So what you can do is use the MaxMind database, which is a database file that maps IP addresses to geographical locations. And using our module, you can then determine the country code of the client IP. And if these people aren't hosted in Belgium, while the CDN is down, we might block the traffic, because the alternative is complete downtime, 100% downtime. And by reducing the amount of people that have access to your platform, you might be able to save 80%. But again, that's a firefighting technique that is only used in extreme situations. So that is an overview of origin shielding, and that also explains the various features. You have waited long enough. We're 25 minutes into it. Let's do a little bit of demoing, if you will. So I have set up, and we're going to leave the slides for what they are right now, and we're going to go to the demo setup. I'll quickly take you through it. I have this website that is available on www.diycdnvarnishsoftware.com. It's a proof of concept, of course. We're never going to release a website that looks like this. But the point is that you have a video player, and you have some text, and I always put in the timer. If you refresh the page and the timer stays the same, it's proof that the object is cached, or the page is cached. This page, if you look at the source, and let's bump the font size a bit, it has to load a CSS file. It has to load in inline CSS a background PNG image, which you can see here. This background needs to be loaded. We have the page itself, of course. We have the logo. We have some JavaScript, and then we have this HLS main.m3u8 file, and that's part of our video tag. That's the source of the video, and that is a playlist file, an HLS playlist file, which is short for HTTP live streaming, where all the video segments are listed. And I'm going to show you how that works. So if I start pressing play, I'll take down the audio. This is just open source, royalty-free video anime that we've modified a bit, and that shows how these things work. So if I inspect my window in Chrome and I go to the network tab, you can see that all these files are being loaded. Every 3 seconds, one of these files is going to be loaded. And these TS files are binary files. They could take up to a couple of megabytes. Okay, let's do fast forwarding here. It will take kilobytes or megabytes, but there's hundreds of them. So if I take you back to the main page and I refresh the page, you will see, let's empty the cache completely. And let's look for the M3U8 file somewhere in this list. Here it is. To some extent, it's not loading, so let's clear it. I must admit, I've been spared by the demo gods for many years, but sometimes small glitches occur. This is it. So it's just metadata prefixed by a hash, and then listing with all the timestamps of all these segments that need to be loaded. And the target duration is 3 seconds. So every 3 seconds, a new video file needs to be loaded. That is the platform. Now, what I will show you now is when I refresh, caching doesn't occur. So let's see if there's cookies that need to be loaded. No. So when I refresh, the timer increases. And that means this is not cached for some reason. So what we're going to do is we're going to look at the DNS setup for this. And we're going to look at how this is configured. So we have a www record. That is our primary record. And that points to our CDN. So if I take this and I load it, it's the CDN that loads the content. Now, what we also need to do is have a further look at the backup. So when our primary record fails, the CDN is not loaded, but we directly go to the origin, which is a pretty bad idea, but that tends to happen. And the origin is just another Amazon instance that is located here, and that serves this content. So I can actually go to origin, load it, and then you can see that the content is not cached. Now, the goal for me, and that's quite ridiculous, is I need to bring down the CDN. I need to simulate a CDN failure. There's no way I can do that in real life. I'm not gonna crash this CDN. I'm using Amazon's AWS CloudFront CDN. There's no way I'm gonna crash this, but I do want to simulate it. And the way I'm going to simulate this is by messing with the health checks. The records are resolved based on the availability of specific endpoints. So what I'm doing here is, this is the endpoint I'm going to, and when I refresh the status, it returns status code 500. So that means it is failing. So we simulated a failure here. So what I'm going to do now is I'm going to refresh it, see what comes out. Yeah, it's not good. And I can check what exactly is going on by doing a dig call. Dig is a Linux command, and I'll try to bump up the font size as much as I can for you. So I hope this works. So I'm going to do a dig call to www.diy-cdn.varnish-software.com. And that will show me what IP address is going to be used. And in this case, the origin takes precedence because there was a failure. And I'm going to show you how that failure occurred. So let's see if I can show this. I tricked the CDN into returning a 500 error. And that means there is a server error, the check will fail. Now, what I will do is I'll restore this, of course. And I was supposed to do this ahead of time. And as we go, and I think in the next 20 seconds, we'll refresh the health checks. So there's an interval of 10 seconds. So every 10 seconds, one of these nodes is going to check this page. And because I uncommented the 500 error, you're going to get HTTP 200s, and that'll be just fine. So let's see what happens. Yes, we're getting 200s right here. So everything is good. So if I do my dig call again, and that depends a bit on DNS caching, look here, we have our CDN. So if I go to www, and let's try this in a separate window, DIY CDN, and we refresh, the page is cached. And I can prove this to you. So if I take this URL, let's do it here, and I do a curl -i, this is just an HTTP call that I'm doing. What you will see here are headers that are specific to AWS CDN. So you see that where I'm calling it from, we're getting sent to our London Heathrow or to the London Heathrow data center of Amazon. Let's open up a separate window and do that from my local laptop. So if I do curl -i and I paste DIY CDN varnish-software.com, www is required here, you will see that I'm served from AWS's Amsterdam data center. So the CDN is in full effect. It works fine. And I've already spoiled it to you, but I'll do it again. I'll close this window and I'll open up the health check, and let's make it fail again. And let's make it fail hard. So again, it's going to take some time for it to take effect. So let's go back to our measuring system here and refresh. Everything's still okay, but as you can see, new errors start occurring. And almost all of them have failed. And let's do our dig call again. What we expect is pretty straightforward. What you saw here is the CDN. Let's clear the screen for your convenience, load it again, and the origin has taken precedence. So what we're going to do now is unleash traffic on it. So what I can do now is run top on Linux, and this is our origin server. And the load is pretty stable. Nothing is happening. This server is not doing anything. So what I'm going to try to do is, I'm not going to completely try to take it down with traffic, but I'm going to try to do a good job. So I'm going to send, let's be nice. I'm going to send 300 simultaneous requests using this command, siege, to our website. It starts now. As you can see, it's doing a pretty good job at it. A lot of data is being sent through. And you can see that there's a lot of Apache processes, so web server process taking place. The load is going up. Let's see if I need to bump up the font size for you. So the load is unbearable at this point. CPUs are spiking. And if we carry on like this, we're going to take the machine down. And that is not the purpose. Our CDN is supposedly down. We need to find a solution. And the solution is to use origin shielding. So let's enable the origin shield. It's already in place. It's this node right here. It's a Varnish node that I installed through our official Varnish Enterprise images that are available on the cloud, on AWS, on Azure, Google Cloud, and other platforms. So it's set up in a pretty standard way. And I configured the configuration file, the VCL file, in which we program the behavior to connect to the origin and cache wherever it can cache. The way we're going to enable this is in our Route 53. Instead of having the origin as the secondary, we edit it and set it to shield so that the shield kicks in. It will take 20 seconds approximately for this to kick in. And we can do our beloved dig call again. If we do dig to www, shield is taking place. So that went quite fast. So we're going to do that all over again. While the load is dropping on this machine, we're going to attack it again. And we're going to be less nice. I'm going to send, again, I'm going to bump up the screen size for your convenience. I'm going to send 800 parallel requests for a considerable amount of time to the same endpoint. And it's going through. And while the load is still 6 as it is recovering, you will see it decline because the traffic is going to this server right here. This is our origin shield. Now, if I look at the load on this machine, the load is very low. It would seem as though this machine isn't doing anything, while the load on the origin server itself, the server that is very sensitive to high load, it is continuously dropping. It is recovering from our first attempts. But you would think that the CDN is back in action, but that's not the case. And I have the stats to prove this to you. So allow me to show you some statistics. So we're using Varnish Stat, which is a built-in program for it. And it will show you what is going on right here. So at this point, there's within the measuring, every measurement, we see 1,390 parallel requests coming in. And the total tally is 150,000 requests have already been processed. And the misses were quite low. So what I'm going to do to prove this to you is I'm going to stop the attack for a second. And I'm going to reset the statistics to 0. So if I do Varnish ADM, stop. So we're stopping the process. We're starting it again. I'm showing you the statistics, and they're pretty low. They're not 0 because all these health checks are connecting to Varnish. And we're going to run the same command again, and you will see it increase. And the misses are quite bearable. Of all that, we're already at 7,000, 9,000, 10,000 requests. Only 4 misses took place, and only 7 connections to the backend were made with this colossal amount of traffic. Well, colossal, that's what I can generate through this server. So the origin shield is really doing its job. But the CDN is bound to come back online again. That is bound to happen. But instead of putting it behind the origin, we'll put it behind the shield. Now, what I will do as a final proof to you is I'm going to send the 800 concurrent requests and show you that everything's fine. So if I go to DIY CDN, the page is loading fine. There is no issue. And I can play the video and it will stream. Let's pick it up in the middle so it has to load other files. Look, that went pretty fast. The video, you can see it might not do it justice due to Zoom. So you might see it as like less than fluent video, but mind you, this is full HD video and it's loading quickly and I'm refreshing the page and all is well while thousands of requests are entering the system. So that's pretty good. So what we're going to do now is we're almost at the end. We're going to stop the onslaught of traffic. We're going to keep the shield as the secondary, but what we're going to do at the configuration level of our CDN is we're going to set the origin. We're going to modify the origin. And the origin is no longer going to be our original origin server, but our origin shield, which is hosted at shield.diy CDN. And that means if the CDN needs to revalidate content, it will do so through Varnish and not directly at the origin level. So it's safe at this point to go back to our terminal, go back to our origin system, and make sure the health check succeeds rather than failing. You've seen this before. I'll show it again. We go back to our health checking and we refresh. It's still all 500 internal server error, but that will improve within, I'm assuming, the next 10 seconds. You can see that our health checking service in Singapore has seen this, one of which in Ireland not, but the other one has. And if I press refresh now, I'm expecting everything to be okay. So let's put it to the test. Clearing the screen, doing the dig command again. And yes, the CDN is processing it. So we go back to our website. We take that URL again, open up a new window, run it. Everything's super smooth again. We press the video. Content is loading, all is good. And as a final command, I'm going to do the curl command again, curl minus uppercase I, send it to the URL, and what we get back again is content served by the CDN located in London. And that's it. That's origin shielding, and that's how you can protect yourself. And that, unfortunately, or fortunately, depending on how you're approaching this, this is the end of the webinar, but it's not the end of the broadcast now, because I'll give you the opportunity to ask some questions. If you want to ask questions right now, there is a dedicated section in our Zoom tool here. There's a Q&A section. You can ask questions and I will answer them live. If you don't have any questions right now or are not up for it to putting them live here and having me answer them in the recording, you're free to send me an email. My email address is right there, thijs.vriend@varnish-software.com, or reach me on social media. Could be LinkedIn, could be Twitter, could be other stuff. I'm at Thijs on all these platforms. So we'll give it a couple of minutes. I'll try to shut up now and give you the opportunity to type your questions. So I get a question here from an anonymous attendee. So I'll quote it literally. How do you detect in VCL if Varnish attempts to fetch cached content that is failed to being non-existent in one of the backends? Well, that is entirely possible in VCL, and there is no one-size-fits-all solution to that. But first of all, the user specified that fetching cached content fails. Well, usually if content ends up in the cache, there is no need to connect to the backend. But if the cached content has expired and it needs to be revalidated and it's not available in the backend, VCL has the options to do so. So maybe you can have multiple backends. If one fails, let's say the content is not existing on one backend, so it might return an HTTP 404. Well, in that case, you can spot the 404. You can check in VCL if the backend response .status code equals 404, then you might want to restart that request and send it to another backend, or maybe send it to the same backend if you think it was a glitch. So long story short, VCL natively has the tools to check. VCL has the tools to check the availability of the backend. VCL has the tools to check the availability of individual content on that backend. So from that respect, I think you're quite safe. However, dear anonymous user who asked me this question, if this doesn't fully answer your question, and if you have more to ask, don't hesitate to just drop me an email. Will Varnish attempt to load from another backend, and on how many times will it attempt with the backends? I don't know the number by heart. There is an automatic retry, but attempting to load from another backend can happen in two ways. You can do that programmatically by defining the scenarios yourself. So what you can do is run a collection of if statements based on criteria you define yourself. Like in the previous question that I answered, it was about a 404 content potentially not being available. But if the backend is unavailable and you want to hit the next one, you can do that perfectly, because Varnish has a module called directors, and that aggregates multiple backends into a single one. It's basically a way to perform load balancing strategies. And health probes are also part of that. So if one of them becomes unavailable, then Varnish will automatically detect that, take that backend out of rotation, and make sure the next one, next request is handled by the right one. Now, meanwhile, if you get one of these errors, you can always trigger a restart until the restart limit has been hit. So to that extent, the unhealthy server will be spotted, will be taken out of rotation, and that same request will be restarted on a healthy server. So Zachariah, I hope that answers your question. Then another question, I heard that Varnish is super fast to serve it from memory. Does that mean if I want to store 200 gigabytes, we need 200 gigabytes of memory? Yes and no. 200 gigabytes of memory is quite a lot, and I'm not sure if your server has that. And there's two ways I want to answer this question. Number one is how bad are your misses? That's a really good quote that I heard a couple of months ago. It's not always about the hit rate, it's about how good your misses are. So let's say you have 8 gigabytes of RAM in your system and the cache is full. So it needs to throw stuff out and revalidate at the origin level. What's the penalty of doing that every now and then? If the penalty is low, and if you can deal with some misses, well, then you're fine. Another thing you need to think of that 200 gigabytes of content, how much of it is hot content and how much of it is like long tail content that is hardly watched. If of that 200 gigabytes of stuff you have in cache, only 10 gigabytes is used very frequently, well, in that case, you only need to assign that amount of memory, knowing that the rest will be served from the origin. If that is unacceptable and you do want to store 200 gigabytes in cache, then you might want to consider the massive storage engine. And that's a very popular Varnish enterprise feature that is used by people who build CDNs or platforms that have to host large volumes of data. And I've shown you the slide. You can set your memory sizing to automatic, so it will assign by default 80% of memory, and all the rest will fall back on disk-based caching, which is not as slow as you think because we've highly optimized it. If you run it on NVMe SSDs, the performance penalty will be little, and you can host terabytes of data from disk in conjunction with memory. So I hope that answers the question. So I won't take any more of your time. It's 1:15 p.m. If you have any more questions, don't hesitate to ask anyone from us or email me or at me on LinkedIn or other social media. With that being said, thank you for being part of it. I had a good time. Hope that applies to you as well. Thanks for being part of this. See you next time.